Welcome back to the channel. In this video, I am going to discuss IGCSE Physics, October-November 2023, paper 21. Let us get started. So before I start with the discussion of this paper, I want you to pay special attention to the last point on the instructions given on the paper itself, which you have to make sure that you are familiarized with the acceleration of free fall to be equal to 9.8 meter per second squared. Just remember to use G equals 9.8 meter per second squared when you do your calculation involved in this paper. Now, the first question, which is a vector quantity? Let me define vector quantity first. Vector quantity is defined as a quantity which has both magnitude as well as direction. Density is a scalar quantity, mass is a scalar quantity, pressure is a scalar quantity, whereas weight is a vector quantity, because the definition of weight is the gravitational field acting on an object which is directed towards the center of the planet or the center of the earth. Directed towards, that's the direction. So D is the answer. Second question, the graph shows the speed of the car traveling through a town. Which section of the graph represents a period when the car is decelerating? Now you look at the word decelerating, it also means negative acceleration. That means the speed is decreasing. So I want you to remember, just look at the graph. This is a speed time graph. So relate the speed time graph to acceleration. How? The gradient of the speed time graph gives you acceleration. So look at A. It seems like it is a straight line graph because starting from origin. So I would say that for section A, the car is traveling at increasing speed, right? Whereas the car is traveling at constant acceleration. So for part A, this is constant acceleration. What about B? B is a curve upwards, going up. So you draw tangent to see whether the car is accelerating or decelerating. Since my tangent line is getting steeper, I would say that section B represents the car is accelerating. What about accelerating? What about C? C, could you see that? Look at the y-axis. At section C, the speed of the car is constant. Therefore, the car has zero acceleration. D, on the other hand, look at the speed is decreasing to zero. So the car is decelerating because the speed is decreasing. So D is the answer. Question number 3, an object reaches terminal velocity after being dropped and falling through air, which graph shows how its speed varies with time. Now, when they ask about terminal velocity, you have to recall, some of the students really memorize the graph of terminal velocity, which is very important. But I would define what is terminal velocity. Now, terminal velocity is defined as maximum speed achieved by the object when the weight of the object is being offset by air resistance. So it is a maximum speed. So say goodbye to D. D is not a possible answer. It could be A, it could be B, it could be C. Now, when you look at the statement again, the question did mention that the object is falling through air. Air resistance, which is one of the resistive forces. When a resistive force is involved here, the graph cannot be a straight line graph. So say goodbye to A. So it is either B or C. Now, I want you to see this word. When I say that the speed is maximum, it could be B or it could be C. And the other point that you should remember for terminal velocity is that even though the speed is increasing to a maximum value, but the acceleration of the object is decreasing. So from a speed time graph, we can definitely find acceleration. No, by the gradient of the graph. Since both B and C gives you the curve graph, I would draw tangent to my curve. Look at B, the tangent, my tangents seem to be increasing. It means that the object is accelerating. This is wrong because in order to reach terminal velocity, the object must be decelerating until the acceleration is equal to 0. Therefore, C is the answer. Question number 4, the table shows the mass and volume of 3 different liquids, X, Y, and Z. The liquids are placed in the same container. The liquids do not mix. Which liquid is at the top of a container and which liquid is at the bottom? Now, recall density because mass and volume are being given. Density is defined as mass per unit volume. Less dense, or the liquid which will be at the top of a container, is the one that has the least density. So it will float. And the one that will be at the bottom will have the most density. Yeah, the denser liquid will sink. So since the informations are all being given, all I need to do is just to find the value of my density. First one is 120 mass, which is divided by volume, which is 200. And I got 0.6 gram per cm cube as my answer for density of X. What about Y? Y 80 over 67 and the density is 1.19 gram per cm cube. And Z is 100 over 120 and I got 0.83 gram per cm cube as my answer. So when you compare all the values of density, you definitely know that X will be floating, Y will be sinking. A is the answer. Question number 5, which moving object has a resultant force acting on it? Now, whenever there's a resultant force, there must be acceleration. Remember that. Let us look at a diver rising vertically through water at constant speed. When the speed is constant, there's no way that you will get acceleration because the speed is constant, meaning to say that the object or the diver is not accelerating. Therefore, the resultant force is equal to 0. So F is equal to 0. And B, an aircraft circling an airport. Circling, this is like circular motion. So when we talk about circular motion or circular track, do you still remember an object which is circulating a track with a constant speed? There must be a force acting on it, which is called centripetal force. Centripetal force is the resultant force that causes an object to travel in a circular motion. So the one that has a resultant force acting on it is B. Search for the keyword. My keyword is circling. Question number 6, forces are applied to 4 identical objects. The length of each arrow indicates the magnitude of the force. Which object is in equilibrium? Since they told you that the length must be indicates the magnitude of the force, you just need to take out your cm rule to do your measurement and compare. And if the object is in equilibrium, it also means that the resultant force acting on the object is equal to 0, and or in other words, the outward force acting on the object is equal to downward force. Just use your cm rule to measure, and I did my measurement. B happened to be the answer. Question number 7, a sphere X collides head-on with a second identical sphere Y, which is not moving or stationary. The mass of each sphere is 0.15 kilogram. Sphere X is traveling at a velocity of 2 meters per second before the collision and produces an impulse of 0.21 Newton second on sphere Y. Now they're bringing so many information here. What is the velocity of sphere X after collision? If I were to read this kind of question, I will be very, very confused. So how do I solve this type of question is that I always sketch a diagram so that I can see better. So this is my diagram. I make my assumptions on the directions of the final velocities of X and Y. It doesn't matter because the question did not even mention what happened to X, whether X is moving in the same direction or opposite direction, right? But no problem with that. I use my principle of conservation of momentum. Total initial momentum of X and Y equals total final momentum of X and Y. If the velocity, because velocity is a vector quantity, if the velocity of X happen to be negative, that also means that the direction that I considered here, I assume X to be moving to the right. That means the direction that I considered here is opposite. So I have to change my direction. That's all. Now, after that, since the impulse is being given, just recall what is impulse. Impulse is defined as the product of force and time, but force is not being given here. No problem with that. That's the second definition of impulse, which is change in momentum. So my minus my minus my uy, that is the impulse of y. I sub in whatever information that I have here. So this is mass x 0.15, initial velocity of x, which is 2, and y uy, initial momentum of y is equal to 0, which is equal to mx is 0.15, vx is the one that I have to find, which is the velocity of sphere x, and y vy, I sub in the final momentum of y as 0.21 Newton second. Why? Because impulse is my vy minus my uy. So anything minus 0, it will end up giving you the same answer. So impulse of y here represents the final momentum of y. So when you work it out, you should be getting vx as positive 0.60 meter per second. Since my answer is positive, so the direction that I considered is actually in the correct direction. Therefore, B is the answer. Now, question number 8, this is repeated past year question. A cyclist travels down a hill from rest at point X without paddling. The cyclist applies his brakes and the cycle stops at point Y. Which energy transfers have taken place between X and Y? I look at X first. The question did mention that start from rest. That means you cannot have kinetic energy at X. So say goodbye to C and D. At Y, the statement did mention that the cycle stops at point Y, so no kinetic energy at point Y. So say goodbye to B as well. Don't you think the answer is very obvious here? The answer is A. Question number 9, an object of mass m falls from a higher shaft to a lower shaft. How much gravitational potential energy does the object lose here? You have to recall the equation of gravitational potential energy. GPE is equal to mg delta h. This delta h means the change in height. So it is equal to mg, the initial height is h1 and the final height is h2. mg h1 minus h2. D is the answer, because that is the loss of gravitational potential energy because the height decreases. Question number 10. A pump does 460,000 joules of work to raise water to fill a tank. It takes 7 minutes to fill the tank. What is the power of the pump? Now, I have to recall the definition of power. Power is defined as work done over time or energy over time. Sub in the necessary information given here. So the energy is 460,000 joules. Since the unit of energy is in joules, you have to bear in mind the time taken must be in second. So I have to change my 7 minutes to second by multiplying 60. So the answer is 1095. Change it to kilowatt to divide 1,000. So I get 1.1 kilowatt, which is A. Question number 11, the water in a swimming pool exerts a pressure at the bottom of the pool. Which graph shows the relationship between the pressure exerted by the water and depth of the water in the pool? Assume the density of the water is constant. Now, water is fluid. And recall the pressure in water. I am going to use P equals rho GH, where rho represents the density of the water. And the question did mention that the density of the water is constant. Remember that? And G, of course, gravitational acceleration is also constant. So from here, you can see when G and rho are constant, P is directly proportional to your H. That means when the H, the depth of the water in the pool increases, the pressure will also increase. C is the answer. Question number 12. Why can a gas be compressed easily into smaller volume? Why? What to do with the gas? Let us look at A. The particles are far apart That is why you can compress it. Is that the exact answer? It sounds correct, but I think that is still lacking of um, far apart. I could agree with that. But I will have to look at B, C, and D first. B, the particles do not attract each other. This one sounds correct, but not accurate at all because they do have intermolecular forces. It's just that the intermolecular forces between the gas particles are very weak. So they will still somehow attract each other with a very weak force. So this is not true. See the particle move randomly. Is it because of them moving randomly? That is why you can compress them. It seems like we are not answering the question. So C cannot be the answer. D, the volume of each particle can be reduced. How can volume be reduced? When you compress it, then only the volume can be reduced, right? That is wrong. Therefore, the answer is A. Question number 13, a gas is contained in a cylinder by a movable piston. The gas is heated so that it expands at constant pressure. Expands means volume increases. How is the force of each collision of the gas particle with the piston affected, and how does the frequency of collisions between the gas particles and piston change? I would say that when the volume increases, so the gas particles have more space to move about. So when they have more space to move about, they would not collide that often. So this is my answer. Gas particles, when the gas is being heated, their kinetic energy will rise as well. So force of each collision will have to increase because they have higher kinetic energy, so they can do more work on each other. Therefore, force of each collision increases. But since the volume increases, they have more space to move about, so they would not collide as frequently. Yeah, so A is the answer. Question number 14. On a warm day, a carton of fresh milk is covered with a wet cloth. Why does this help to reduce the temperature of the milk? This has something to do with covered with a wet cloth. Okay, I will have to read the question, all the choices one by one and explain it one by one. A, some water evaporates, which is true from the cloth because that's a warm day. And so the remaining water becomes cooler. Do you still remember evaporation causes cooling effect? So this is true, but I will prove B, C, and D are wrong. The water has a very high specific heat capacity. That is not why the temperature of the milk reduce. So this is wrong. C, the water insulates the milk. No, that is wrong. Water is always colder than the air around it. That is not true as well. So A is the answer. So yes, recall evaporation, which causes cooling effect. Question number 15, a chef heats some water in a pan on a hot plate. The temperature of the water rises by 10 degrees Celsius in time t. She then puts in the same volume of oil in an identical pan on the same hot plate. Specific heat capacity of the water is 2.5 times of that of oil, and water is 1.1 times denser than oil. What is the time for the temperature of the oil to rise by 10 degrees Celsius? Well, this seems to be a lot of information for me to process. I would recall the equation that I'll be using. Since the specific heat capacity is being given, I will recall this equation. E equals mc delta T. E represents the heat supply or the thermal energy supply. M represents the mass. C represents the specific heat capacity. Delta T represents the change in temperature. And mass is not being given. So I have to recall the equation or the formula of the density. Density is defined as mass per volume. Therefore, mass is equal to density times volume. And I sub into the equation, I have my E equal to rho V C delta T. Power is equal to energy over time because the power is being given, and I have energy is equal to power times time. So I sub in, this is my final equation that I will be using to solve this question. Power times time is equal to rho V volume C delta T. So I do it one by one. Power times time is equal to rho W. That means the density of the water. Volume of the water, specific heat capacity of the water times the change or in temperature of the water, which increases by 10 degrees Celsius. So I sub in, and I got this all information given. The specific heat capacity of the water is 2.5 times the specific heat capacity of the oil. I put this as 1. And the density of the water is 1.1 times the density of the oil. But the volume of the water is equal to the volume of the oil. And, okay, I get my first equation first. I sub in the density of the water as 1.1 times the density of the oil. Times the specific heat capacity of the water, I sub in as 2.5 times the specific heat capacity of the oil, times 10, which is the increase in the temperature of the water. I put that as my first equation. And the second equation, P, which is the power of the heater times the time taken for the oil to be heated up. So density of the oil, I put density of the oil, specific heat capacity of the oil, and volume of the oil times the rise in temperature of the oil. So since I have two simultaneous equations, so I can solve it. I use the second equation, divide the first equation, power and power, you can just cancel it off. Density of the oil, volume, volume, 10 and 10. So, and specific heat capacity of the oil can be cancelled off as well. So the time taken for the oil is equal to time taken for the water over 1.1 times 2.5. And I have 0.36 as the answer. So 1 times 2.5, just do my double checking here, which is, yes, 0.36 T is the answer. So the answer is A. Question number 16, the diagram shows the view of a room heated by a radiator. The arrowed line from X to Y is the path of a convection current in the air, which roll about the air temperature and the air density at X and Y is correct. So I want you to remember density is defined as mass per volume. And the heat always flow out from hot to colder region. So the temperature, air temperature is always higher than X because the radiator is the one that gives out the heat. So A and B could be the answer. A or B could be the answer. But the air density, so since hot air has higher volume, because hot air, when the air is hot, so the air particles gain kinetic energy, so they will expand. So their volume increases, which decreases the density of the air particle. That is why they can rise compared to Y. So the density of X is lower. So higher at Y. B is the answer. The next one, question number 17, two men, P and Q, stand close to a gap in a wall as shown. Man P cannot see man Q, but man P can hear man Q speaking. Which statement explains this? Let us look at A. Light waves do not diffract at all because they are electromagnetic waves. For your information, all the waves, whether they are electromagnetic waves or not electromagnetic waves, they will undergo diffraction. So this is wrong. B, light waves have a range of frequencies, but sound has just one frequency. Is that because of that the man P cannot see man Q but can hear man Q? That is not true. C, sound waves are of higher frequency than light wave. Never. D, if sound wave are of higher frequency than light wave, then we could not hear the sound wave. These sound waves diffract a lot because their wavelength is similar to the size, to the width of the gap. That is very, very true. Because as long as diffraction occur, for a clear and visible diffraction, the wavelength of the wave must be almost similar to the size of the gap. So D is the answer. Question number 18, which quantities relating to a wave on the surface of water can both be measured in meters? I will look at A first. Amplitude can be measured in meters, but frequency can be measured in 1/2 or in hertz. So A cannot be true. B, amplitude can be measured in meter. Wavelength can also be measured in meter. Yes. Amplitude can be measured in meter. Wave speed must be measured in meter per second. Frequency is measured in 1/2 or in hertz. So B is the answer. Question number 19, the diagram shows part of a ray diagram that demonstrates the formation of a virtual image Y of object X by a converging lens. One ray of light from X is shown approaching the lens. Which arrow shows the direction of this ray as it leaves the lens? I would say that the ray as it leaves the lens. You have to memorize for ray diagram, any rays that is parallel to the principal axis. What is principal axis? Principal axis is a horizontal line that passes through the center of the lens. Any ray that is parallel to the principal axis would be refracted towards focal point. So A is the answer. Question number 20, a ray of light is reflected by a plane mirror. Which row shows the angle of incidence and the angle of reflection? Angle of incidence is the angle between the incident ray, the ray that is directed to the plane mirror. Between the incident angle, between the incident ray and the normal line. The normal line is a line which is drawn perpendicular to the surface of plane mirror. So Q is the angle of incident. So Q is the angle of incident. Reflected angle is the angle between normal and the reflected ray, which is R. So C is the answer. Question number 21. A thin converging lens is used to produce a real image of an object. Which statement about the real image is always correct? A, it is nearer to the lens than the object. It is not incorrect. B, the real image must be formed at the opposite side of the lens, which is true. It is not always same size, and it is not always upright as well. So the one that is always true is B. Question number 22, a radio transmitter broadcasts at a frequency of 200 kilohertz. What is the wavelength of these radio waves? Now, it seems that we have lack of information here, but you have to recall the wave speed. V equal to F lambda. And radio wave is one of the electromagnetic waves which travel with the speed of light. Speed of light is 3 times 10 to the power 8 is equal to frequency which is given 200 kilohertz. You have to change that kilo to hertz. You just times 1000 times lambda, and you have your lambda, which is the wavelength, which is equal to 1500 meter, or C. Question number 23, the element mercury exists as a solid, a liquid, or a gas. Which row gives a possible set of values of the speed of sound through mercury? So when mercury is frozen, it's just like the speed of sound in solid. So speed of sound in solid must be the highest. Speed of sound in air, vapor, is like air, must be the lowest one. So D is the correct answer. Question number 24, which metal could be used for a permanent magnet and which metal could be used for the core of an electromagnet? For a permanent magnet, there's only one, which is steel. The core of the electromagnet, you see the word electromagnet, this is soft iron core, so D is the answer. Question number 25, which statement describes the direction of an electric field at a point? Let us look at A, the direction of the force on the negative charge. No, that is not the definition of electric field. B, the direction of, you see the North Pole, you see the South Pole, that is wrong. That is related to magnetic field. So the direction of the electric field is in the direction of positive charge. Question number 26, which statement about a voltmeter is correct? A, it has a scale which is marked in amperes, or A, that is related to ammeter. So this is wrong. B, it must be connected in series with the circuit that is related to ammeter as well. So this is wrong. C, it measures potential difference. Wow, that is true. It must have 3 terminals. No such thing, right? So C is the answer. C is the answer. Question number 27. A wire has a resistance of 8 ohm. A second wire of the same material has twice the length and twice the cross-sectional area. What is the resistance of the second wire? You have to recall the relationship between resistance and length and resistance and cross-sectional area. Resistance is directly proportional to length. That means longer the length, larger the resistance. But the resistance is inversely proportional to cross-sectional area. That means larger the cross-sectional area of the wire, resistance drop. So I combine these two. I have resistance is directly proportional to length but inversely proportional to cross-sectional area of the wire. And I just want to get rid of this proportionality symbol. I put a K here. That K means constant. R is equal to constant times length over area, surface area. So I have to find the resistance of the second wire. I just put it as R new. But the second wire has twice the length of the first wire and twice the cross-sectional area of the first wire. So I put in 2A and 2L. I solve for these two equations. I have, for this second equation, I'm going to do it here. R new is equal to K. Could you see that 2 and 2 can be cancelled off? L over A. Can you see that I get back the same equation as the one that I formed in the first equation? So no change in the resistance because mu R is the same as the R of the first wire. Therefore, the answer is B. Question number 28. A plastic rod is rubbed with a cloth. The rod becomes positively charged because of the movement of the charged particles. Which row gives the name of these charged particles and the direction in which they move? And there are only 2 charged particles, which are protons and electrons. You have to bear in mind the charged particles that can move is only electrons. So say no to C and D. And since the rod becomes positively charged, that means the electrons have already moved out from the rod. So the electrons are moving from the rod to the cloth. B is the answer. Question number 29. An alternating AC supply is connected to a diode and a resistor in series. Which graph shows how the potential difference V across the resistor varies with time t? Whenever you have a diode here, diode can only allow the current to flow in one direction. So whenever current is in the positive direction, the diode will allow the current to flow through. But whenever this is a negative direction of the current will be blocked, will be cut off. So C is the answer. Question number 30. The diagram shows the circuit used to switch on a heater when the temperature drops below a certain value. Which row shows the components that could be connected at X and Y? So I look at Y first because this is related to temperature. So I would say no to A and C because Y here is LDR, light dependent resistor. It has nothing to do with light. It has something to do with thermistor because thermistor is related to temperature change. So I would connect the thermistor to Y and fixed resistor to X. B is the answer. Question number 31. A current in a solenoid produces a uniform magnetic field inside the solenoid. Magnetic field direction is due east. I have to draw the direction. North, east, south, and west. Now the direction is due east. And which changes will produce a stronger magnetic field with a direction due west? I want in the opposite direction. When it is in the opposite direction, let us see, use a smaller current. Use a smaller current would never produce a stronger magnetic field because magnetic field depends on the amount of current. So say no to smaller current. Use a larger current and turn the solenoid through 90 degrees. That will only produce a stronger magnetic field because maximum cutting of magnetic field occur. But it will not produce the magnetic field in the direction due west. So this is not true. Use a larger current and reverse the direction of the current. Yes, that will produce the direction due west. Question number 32, a metal rod PQ rests on two horizontal metal wires that are attached to a battery. The rod lies between the poles of a magnet. When the switch is closed, the rod moves to the right, which is in this direction. What could be changed so that the rod moves to the left? If I open the switch, why the rod? Let me explain. Why the rod move to the right first? Could you see here? Okay, I'm going to draw it out. These are two magnets and magnetic field is flowing from north to south. And when the switch is closed, there will be current passing through the wire, which gives rise to the magnetic field inside the wire. The interaction between the magnetic field of the magnet and magnetic field of the wire gives rise to the magnetic force, which push the metal rod to one side, which is to the right. So what could be changed so that the rod moves to the left? When you open the switch, there is no magnetic field in the wire. So when there is no magnetic field in the wire, there is no interaction between the two magnetic fields and there is no force. So the metal rod will remain stationary. So this is wrong. B, reverse the battery terminal and exchange the pole of the magnet. If you reverse, this will become negative terminal and the magnetic field from the magnet will flow outwards. It will make the rod move to the right because you change both things, right? This is not going to make the rod move to the left. C, reverse the battery terminal, but without changing the poles of the magnet. So you reverse the battery terminal, so the current flows in the opposite direction. So the magnetic field in the current will flow in the opposite direction. So the interaction between the magnetic field of the magnet and the opposite direction of the magnetic field of the current will make the rod move to the left. This is true. Or you can use your Fleming's left-hand rule. And D, turn the metal rod around, P and Q exchange. No, it would not make the rod move to the left. So this is not true. C is the answer. Question number 33, a transformer in a computer is used to transform the mains voltage of 240 volt to 12 volt. The number of turns on the secondary coil is 2000. Which statement about the transformer is correct? Now, I want you to recall the equation or the ratio that I use in transformer since the number of turns in the secondary coil is given. So I want to find the number of turns in the primary coil. So NP represents the number of turns in the primary coil over a number of turns in the secondary coil is equal to voltage in the primary coil over voltage in the secondary coil. Now, NP over 2000 is equal to 240 over 12. So my number of turns in the primary coil is 4000. So I look for 40,000 is the answer. So A cannot be the answer, C could not be the answer. So it is either B or D. So I have to look at this is the primary voltage, this is a secondary voltage. It seems that the voltage is being stepped down. I would say that this is a step down transformer and with 40,000 turns on its primary coil. So B is the answer. Question number 34. In alpha particle scattering, alpha particles are incident on a thin metal foil. Which row describes results from the experiment and a conclusion that the results lead to? Look at A. Most of the alpha particles pass straight through the coil, which is true. The conclusion is because most of the atom is empty space, which is true, but I will have to look at B, C, and D first and compare. B, most of the alpha particles pass through the foil, which is true because the nucleus is very large. No, the nucleus is very small. This is wrong. C, very few of alpha particles pass through the foil. This is not true because more 99% of the alpha particles pass straight through the foil. D, very few of the alpha particles pass through the foil. This is wrong. Therefore, the answer is A. Question number 35. Alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei when they decay. Which emissions can be deflected by electric field? The one that is not being deflected is gamma ray because gamma ray is FOC, free of charge. So say no to gamma and gamma and gamma. So the answer is B. But of course, I will explain what's alpha particle. Alpha particle is a helium nucleus, 42He. Beta particles is a fast-moving electron with the negative charge. Question number 36. Radioisotope X decays to the stable isotope Y. The graph shows how the mass of Y present in a sample varies with time, which Y will be increasing due to the decaying of X. Which time interval gives the half-life of X? Half-life of X is when X decays to half of its initial value. The half of its initial value is the half of Y being present. So m/2. That gives you half-life at T2. C is the answer. Question number 37. Which particle is absorbed by a nucleus to cause nuclear fission? So only neutron is being absorbed. Question number 38. It is summer in the northern hemisphere of the Earth in June. Which statement explains why? The Earth is closer to the sun in June. Not true. Not very true. B, the Earth spins on its axis in the opposite direction to that in which it rotates around the sun. That is not the explanation to why there's summer. C, the moon is full in June. That is not the explanation to why there is summer in northern hemisphere. D, the North Pole, yes, because this is related to northern hemisphere. North pole of the axis of the Earth's rotation is tilted towards the sun in June. That is why the north part is facing the sun, yeah, which is closer to the sun. D is the answer. Question number 39. Which statement about the sun is correct? A, the sun is a dwarf star. No, the sun is not a dwarf star. The dwarf star is Pluto. Pluto is a dwarf planet, sorry. Yeah, sun is not the dwarf star. B, the sun is a giant star. It is not yet a giant star. It is on the road to becoming a giant star. Those say no to this. C, the sun is a medium-sized star, which is true, consisting mostly hydrogen and helium. That is very true. D, the sun is a medium-sized star consisting mostly nitrogen and oxygen. That's not true. Question number 40. The table lists some information about some stars. Which star will eventually explode as a supernova? Wow. Okay. The star that, I don't really memorize the name of the star, but I look at the type of the star. The type of the star that will explode as a supernova is red, super giant, because you are super big, then eventually you will explode as supernova. So B is the answer. So that's the end of the discussion. Thanks so much for watching. I hope this video will help you to understand physics, and good luck in your coming exam. So thank you very much for watching. See you in my next video. Bye.